Imagine you have just built the perfect AI-powered industrial drone. It is fully assembled, boxed, and sitting on a pallet ready to ship to the United States. But that pallet sits in a warehouse for 6 months, burning through your company's cash flow every single day.
Because China has answered the latest American technology restrictions not with a loud, sweeping embargo, but with a quiet, targeted tightening of administrative procedures.
Right. Beijing has tightened reviews for U.S.-bound drones, prohibited domestic dealings with 7 American organizations, restricted U.S. agencies from conducting certain follow-up factory certification inspections inside China, and opened a national security investigation into imported office equipment. If you're managing a supply chain today, you need to look very closely at that list.
We'll look at the margin data first.
Mm.
The sweeping chip ban is highly visible, it makes headlines. A certification delay is quiet, but for the company waiting on that approval, the financial reality on the balance sheet is identical.
Because a product launch slipped by a quarter. Inventory remains unfinished and simply cannot be monetized.
And revenue shifts to the next fiscal year. Your working capital stays trapped inside a piece of hardware that cannot legally reach your customer.
So the core thesis we are looking at today is that the U.S.-China technology conflict is no longer confined to the high-profile realm of advanced semiconductors. It is aggressively moving into the bureaucratic procedures that dictate testing, manufacturing, and customs clearance.
The political language always centers on national security or technological leadership, but the commercial mechanism operating underneath is much narrower.
Meaning, a government does not actually need to stop an entire industry to exert leverage. Washington restricts access to a component, a network, or a market. Beijing answers through export licensing, certification friction, entity restrictions, or controlling critical material.
Exactly. A regulator only needs to control one approval, one raw material, one laboratory test, or one required document that your finished product cannot function without.
Let us trace this by following that hypothetical drone we just mentioned. Semiconductors really set the template for this new architecture.
They did. American restrictions initially targeted advanced computing chips, semiconductor production equipment, selected software, and technical support.
And the control system extends well beyond the processor itself. Exporters have to identify the product classification, the ultimate owner, the destination, the intended application, and even whether the technology could be diverted through a third country.
Which means an export control is no longer just a legal prohibition you hand off to outside counsel. It functions as a massive internal compliance architecture.
So if you look at the internal corporate friction, the cost hits the legal department first, which flags the risk. Then procurement must manually trace the supplier network.
And engineering may be forced to substitute a component mid-cycle. Sales has to verify whether the end customer is still permitted to receive the product. One single restriction moves across 4 different corporate functions, draining resources before the shipment ever leaves the factory floor.
We are seeing this exact pattern in Gulf communications equipment right now. The Federal Communications Commission has expanded restrictions covering Chinese telecom, surveillance, routing, drones, robotics, power inverter, and network technologies.
And crucially, there is a tightened rule intended to prevent covered Chinese components from entering the U.S. market hidden inside products that carry a completely different brand name.
Well, follow that logic carefully, because it fundamentally alters your traditional procurement strategy. The finished device sitting on the shelf might be sold by a trusted American, European, Korean, or Taiwanese brand.
The badge on the outside is essentially irrelevant now. The regulatory exposure originates from the origin of the internal System 1 communications chip, a camera module, or a routing component supplied by a covered Chinese entity.
So supplier selection is completely inverted. You can no longer just ask engineering if the component works and ask procurement what it costs.
Management has to forecast whether the supplier might be added to a government list in 2 years, whether the testing laboratory will keep its recognized status, and whether ownership rules could suddenly shift.
That uncertainty has to be priced into your total landed cost. The cheapest component on your initial purchase order routinely becomes the most expensive component in your supply chain.
Once you factor in the cost of redesign, recertification, excess safety stock, and warranty retesting, the commercial invoice only shows the purchase price, but the income statement is now absorbing the political risk.
Let us bring this back to the drone market to demonstrate how quickly security policy restricts actual operating capacity. The U.S. has restricted approval of new Chinese drone models and expanded scrutiny of critical components.
And China's response, as we noted, is a new rule requiring stricter case-by-case review for drone components bound for the U.S., specifically flight control hardware, motors, infrared equipment, and navigation systems.
They remove the streamlined licensing. Procedure literally becomes lead time, and we have to recognize that drones are critical industrial assets.
Right, these are not consumer toys used for aerial photography. If you are operating in the industrial sector, drones are used to inspect high-voltage transmission lines, survey commercial construction sites, and map agricultural farmland.
They're also used to assess severe storm damage for insurance adjustments and support public safety networks. So a delay in a single motor or infrared sensor creates immediate economic ripple effects across utilities, agriculture, and construction.
You are bottlenecking broad economic productivity based on specific hardware delays. But the friction does not stop at the component level.
No, it does not. Certification is the second, perhaps more insidious, choke point. Let us look at the administrative retaliation layer.
According to Reuters industry data, roughly 75% of electronics destined for the American market are tested in China.
At the same time, the FCC has proposed restricting Chinese testing labs, and Beijing has restricted U.S. agencies from participating in mandatory Chinese certification inspections. Think about the capital expenditure required to respond to that.
Testing may have to move entirely. A manufacturer might need to secure a different inspection provider in a completely different time zone.
Work that was already completed and paid for in one jurisdiction may need to be entirely repeated in another to satisfy a different set of regulators. Essentially, companies are having to hire a team of private investigators just to figure out who actually made their routers.
And then they have to pay to test that router twice. Governments are now deciding who is trusted to verify that a product complies with the rules.
A laboratory certificate used to simply establish technical conformity. Today, it is increasingly operating as evidence of political trust.
Large multinationals might have the cash flow to build parallel testing routes, retain external counsel, qualify backup labs in third countries, and maintain duplicate documentation systems.
But smaller competitors do not. They face the exact same regulatory burden with fewer personnel and far less cash.
Which means this market fragmentation heavily rewards balance sheet capacity. The company that survives this environment might not actually have the most innovative product.
They just have the financing required to outlast smaller competitors who burn through their working capital trying to maintain duplicate compliance systems. We are seeing AI infrastructure emerge as the absolute ultimate test of this balance sheet capacity.
The U.S. administration is weighing a potential restriction on imports of new Chinese optical transceivers used inside data centers. Now, to be clear on the data, this proposal remains under development.
It could be modified, it could be abandoned entirely, but the trajectory is clear. Policy is aggressively moving for controlling the advanced processors themselves toward targeting the ecosystem surrounding them.
Right, because an AI cluster is not just a collection of GPUs sitting in a rack. To actually operate, it requires optical links, switches, high bandwidth memory, advanced liquid cooling hardware, power inverters, and network software.
Protecting your access to the core processor while remaining completely dependent on a strategic rival for the surrounding infrastructure creates an obvious vulnerability. The scale of that dependency is massive.
We have the specific Reuters industry data here. Chinese companies accounted for more than 50% of global optical transceiver shipments last year.
But that raises an immediate strategic contradiction. Washington has two primary directives right now. They want to deploy AI infrastructure and secure data center capacity as rapidly as possible to maintain technological dominance.
At the exact same time, they want all of that hardware meticulously screened for cyber risk, foreign control, and the possibility of remote disruption.
Well, let me stop you there because that assumes those two goals can coexist. If you restrict suppliers who control over 50% of the global market for optical transceivers, aren't policymakers just restricting their own capacity?
That is the exact trade-off. Can alternative producers actually expand manufacturing capacity fast enough to replace half the global supply without causing massive delays? Security and industrial speed are pulling in completely opposite directions.
Both objectives are defensible from a policy standpoint, but they do not produce the same procurement decision on the ground. If you prioritize speed, you buy the available Chinese transceiver.
If you prioritize security, you wait 18 months for an alternative facility to come online in another country. And this extends far beyond AI.
It reaches routers, connected power equipment, industrial robotics, and submarine communications infrastructure. The common denominator is connectivity.
The regulatory concern is no longer just what a device does mechanically, it is what that device can transmit, update, observe, or potentially disable remotely, which is forcing a shift in corporate strategy from demanding trusted products toward demanding trusted architecture.
You cannot prove a final device is secure if you cannot identify who designed the foundational firmware, who supplied the wireless module, which specific lab tested it, and who holds the access keys to modify it after installation.
The goal here is not entirely domestic supply chains. That is mathematically impossible for most hardware.
The real question is how much redundant capacity companies are willing to finance, and which dependencies remain completely unavoidable after they have spent that capital. Let us pivot to supply chain verification, because forced labor enforcement introduces an entirely different form of institutional power.
The United States recently added 43 Chinese companies to the Uyghur Forced Labor Prevention Act Entity List, the UFLPA, bringing the total to 187.
These additions cover electronics, battery materials, metals, and the food sector. Goods made wholly or partly by listed entities face a strict legal presumption.
They cannot enter the U.S. unless the importer provides sufficient evidence to prove no forced labor was used. China, for its part, firmly rejects the allegations and has condemned the restrictions.
The critical operational point for the listener is that your regulatory exposure does not stop at the listed company. You could be an American importer buying finished goods from a Tier 1 supplier in Malaysia, Vietnam, Thailand, or India.
You still carry the legal burden to establish exactly where the upstream raw materials originated. The physical address printed on your commercial invoice is insufficient. You have to map the upstream chain.
Let us look at the exact customs data to see the financial mechanics of this. According to figures reviewed by Reuters, $3.26 billion, or roughly 82% of the value of shipments stopped under the UFLPA, consisted of semiconductor devices associated mainly with solar panels and cells.
But here is the most crucial metric. More than 79% of the value of those halted shipments was eventually released into the market. Focus on that 79% release rate because it highlights how detention functions in the real world.
A shipment does not need to be permanently rejected by customs to destroy a company's cash flow. Think about what happens during a 4-month delay.
The importer must finance dead inventory. Port storage charges compound daily. Downstream assembly lines halt because they lack components. Well, I want to underline what you're saying because this changes the entire framework. Are you saying a customs delay is not just a logistical headache? It is actually functioning as a deliberate financial weapon.
By simply pausing a shipment for review, the government forces the importing company to absorb the financial penalty of uncertainty. Detention is a working capital instrument.
The government might review the paperwork and ultimately release the solar panels 6 months later, but the company still carried the massive financial cost of that uncertainty.
Verification itself becomes strategic infrastructure, which perfectly explains why several of the American organizations targeted in China's recent retaliation work in areas related to certification, supply chain mapping, labor risk assessment, and human rights research.
The conflict has moved toward controlling the accepted answer. Who produced the material? Which factory performed the final assembly?
Which laboratory tested the electrical conformity? And most importantly, which third-party organization is trusted by the government to verify that evidence? If you control the accepted proof, you control whether the shipment moves. And China holds a distinctly different form of leverage when we look further upstream at critical minerals. Export controls and licensing delays are making certain materials incredibly difficult for U.S. manufacturers to secure.
A survey by a U.S. business group noted that roughly 75% of affected companies are actively seeking alternative, non-Chinese supplies.
Rare earth magnets are the prime bottleneck here because China does not just dominate the raw mining, they dominate the refining, the alloying, and the final magnet manufacturing.
Because simply owning a mineral deposit in Australia or North America does not magically create a qualified aerospace component.
The supply chain requires highly complex chemical processing, specialized milling equipment, trained metallurgists, rigorous customer validation, and enough operational volume to make the margins work.
You can open a brand new mine tomorrow, and the downstream processing bottleneck remains exactly the same.
But wait, I see headlines every day about tech companies aggressively moving their assembly lines out of China and into Vietnam, Mexico, or India. Doesn't this strategy of friendshoring bypass that bottleneck and solve the dependency problem?
It is a highly visible illusion. Moving final assembly to Mexico might satisfy a tariff requirement or look good on an investor slide deck, but it does not remove the Tier 2 and Tier 3 Chinese components from your bill of materials.
A factory in Monterey can slap a Made in Mexico sticker on the device, while still depending on the exact same upstream chemical processors and magnet suppliers.
So a company can spend hundreds of millions of dollars to relocate a production line across the globe, only to have the entire line grind to a halt because a single rare earth magnet or chemical input is stuck in customs.
Final assembly is visible to the consumer. Dependency is buried 3 tiers lower in the subcomponents. Adding to this friction, Beijing has placed selected U.S. companies, specifically in rare earth and defense supply chains, on their own export control lists.
And even if those specific U.S. defense firms do not have major commercial operations inside China, the broader market psychology takes over.
The shadow of regulation is always much wider than the written rule. Risk perception dictates market behavior.
A formal restriction only targets one specific transaction. But in response, a commercial bank will suddenly request 50 pages of extra documentation to clear a payment.
A logistics insurer will hike their premium to cover the geopolitical risk. A third country distributor in Europe or Southeast Asia will simply decline a perfectly lawful order because they want to avoid any appearance of political sensitivity.
Which brings us to the macro outlook. If you are modeling this over the next 12 to 24 months, there are two plausible scenarios.
Outcome 1 is a calibrated conflict. Washington and Beijing keep restrictions highly targeted. Licenses continue to be granted for lower-risk consumer products.
Companies adapt by qualifying dual suppliers, regionalizing their testing labs, and carrying heavier safety stock without totally abandoning either market. Trade continues, but at a permanently higher structural cost.
Geopolitical security simply becomes another standard operating expense, right alongside quality control and insurance. Outcome 2 is where administrative retaliation becomes self-reinforcing.
A U.S. technology restriction triggers a Chinese export review on a critical mineral. That review leads to another U.S. entity listing. In response, Chinese testing bodies lose their mutual recognition status.
U.S. Customs then demands triple the documentation. Neither government ever holds a press conference to announce a formal decoupling, but the daily operational reality functions exactly like one. Let us run through a crisp 30-second summary of the strategic winners and losers in that environment.
For winners, you are looking at companies with multiple qualified suppliers across different jurisdictions, regionalized production, and highly credible traceability software. You also need patient capital that can absorb delays and adaptable product platforms that can swap out components without requiring a total redesign.
And the losers are smaller manufacturers lacking cash reserves, single-source procurement systems, export-dependent tech firms, and any product utterly reliant on a single, difficult-to-replace component.
And of course, the consumer consequence is inevitable: higher retail prices and delayed product launches. Because resilience in this era is not measured by how many tariffs a government can levy or how much trade they can block.
True resilience is measured by whether your domestic economy can actually produce the required system after the blocked supplier disappears. It really makes you wonder if the next global conflict is not fought with advanced weaponry, but with missing paperwork, testing certificates, and administrative delays. Are the real strategic superpowers of tomorrow going to be the compliance auditors? Tell us which layer now carries the greatest strategic power: advanced chips, critical minerals, product certification, or supply chain verifications. Subscribe to the Unlayered Global for more analysis of the money, technology, and institutional power beneath the geopolitical headline.